In this video, we are going to talk about the spherical mirrors, the concave and convex mirrors. What we call spherical mirrors is when you complete the mirrors, you get a sphere as in the figure. Now, this one is a concave mirror. This is the back of the mirror, and this one is the front, and this one is a convex mirror, W1. This is the back of the mirror, and here is the front of the mirror. Now here we have a circle and a sphere in 3 dimensions. The midpoint is the center of curvature, so this is the radius of curvature. We call as a symbol C for the center of curvature. The midpoint between the mirrors and the center of curvature is called focus with a symbol F. Also in a convex mirror, the midpoint between center of mirror is focus, which we call F. So you see here that the focus and center is in front of a concave mirror, but the focus and center is at the back of a convex mirror. And the distance between the mirror and the focus is equal to the distance between the focus and the center, which we call the focal length. F is the focal length of spherical mirrors. So here you can see that the radius of curvature is equal to 2 times the focal length. Now let's see the reflection from a concave mirror. This is our incident ray. We draw a dashed line passing from the center to the point where the incident ray intersects with the mirror. This acts as normal, as you will remember from the plane mirrors. The angle between the incident ray and the normal is called the angle of incidence. So again, the angle of incidence should be equal to the angle of reflection. This is my reflected ray. This is reflected ray, and this is the angle of reflection. So angle of incidence should be equal to the angle of reflection. Here what is important, the line passing from the center acts as normal, so it also obeys the law of reflection in plane mirrors. And we have some special rays in concave mirrors. One ray coming parallel to the principal axis is reflected back passing through the focus. To the reverse of one, ray coming passing through the focus is reflected back parallel to the principal axis. 3. Ray coming from the center of curvature is reflected back along its original axis because this line acts as normal. As you will remember from the plane mirrors, the ray coming perpendicular to the plane mirror is reflected back on its way. And the last one, ray coming to the vortex point is reflected making the same angle with the principal axis as the incident ray, because this is the angle of incidence and this is the angle of reflection, and according to the law of reflection, angle of incidence should be equal to angle of reflection. So here the principal axis acts as normal. Now let's see the reflection from a convex mirror. Again, a incoming ray we draw a dashed line passing from the center of curvature, which acts as normal. So the angle of incidence should be equal to the angle of reflection. So it is reflected as this way. This is a general reflection obeying the law of reflection. But we have some, again, special rays in convex mirrors which we use mostly. One, ray coming parallel to the principal axis is reflected back as if it is coming from the focus. So look at the extension of the reflected ray. It is passing from the focus. The second one, ray whose extension, see here, this is the incident ray, its extension is passing from the focus, so it is reflected back parallel to the principal axis. Ray whose extension is passing through the center, this line acts as normal, so it is reflected back along its original axis. And the last one, ray coming to the vortex point is reflected making the same angle with the principal axis. The angle of incidence should be equal to the angle of reflection. Again, here the principal axis acts as the normal. Now let's make a review. In a concave mirror, we draw our principal axis. This is our focus. This is our center of curvature. The ray coming parallel to the principal axis is reflected back passing through the focus. The second one, ray coming from focus is reflected parallel to the principal axis. Ray passing from the center of curvature is reflected back on itself, and ray coming to the vortex is reflected with the same angle, making with the principal axis. And as a review of a convex mirror, we draw our convex mirror, put our focus and center of curvature. Ray coming parallel to the principal axis is reflected as its extension is passing through focus. Ray coming whose extension is passing through focus is reflected as parallel to the principal axis. Ray whose extension is passing from the center of curvature is reflected back on itself, and ray coming to the vortex makes the same angle with the principal axis as it is reflected.